Okay, so this is our little review graphic organizer. Your fall exam is not really a fall exam, like over the whole fall semester. It's just going to be over the third 6 weeks only. So there were 2 units in that, Unit 4 and Unit 5. So this first part, quadratics, okay, that's what you just test over. So I'm not going to do this first because that's the most current information. What I want to address is the second page, systems. That's Unit 4. So what I did is I tried to give you some key information and some facts and then an example to an example problem, a test-like problem, okay? So if we're going to solve systems graphically, we're going to have to use the slope-intercept form, and we have to know the different types of solutions. So you can have one solution and a couple things. If it'll let me get to it, there it goes. That is the actual point where those lines intersect. That is your solution. And so it's always going to be an ordered pair. So you have to have an X and a Y. If it's one solution, this is what we call a consistent independent. Okay. If it's the same line, which means you have the infinite solutions, okay? You're going to have 2 equations, but they come out to be the same line. Now, if I was working this out algebraically and not graphically, infinite solutions are basically true statements, or always true statements. It turns into, let me go back. I'll make the little star here. They are always true statements. Okay, running out of a little room. For example, like I know 2 always equals 2. Okay, 1/2 always equals 1/2. It does not equal anything else. If I come up with 2 constants equal to each other, that is always true. So this would be infinite solutions. And infinite solutions are consistent, but they're dependent. Now, when I'm looking at an inconsistent, this is when we have parallel lines. This would be no solution. And this is when we would have a false statement. Okay. I'm going to have to fix this tablet because the font is coming off a little crazy. So, for example, I can't have 2 equal 3. That's false. Okay. So if I came with the result like this, it would be a false statement. Now, whenever solving graphically, okay, and I can't stress this enough, okay, your equation be in slope-intercept form. Which means it has to look like y equals mx plus b. If it does not look like that, that's where the work comes into play. You have to solve for y. You have to put it in that form so that you could graph it. Okay, so this is your example of that. Both of these 2 equations are in standard form. So the first thing you're going to need to do, I'm going to put up here first. The first thing you're going to need to do is solve for y. Okay? What that consists of when you're solving for y, you're going to add or subtract x. I'll put a little arrow there. And I'm going to abbreviate subtract. Add or subtract x, and then you're going to have to divide by y. Okay? So, in a problem like this, for this first one, and I'm going to do this first one in blue so we can kind of color code them, is some of you think of it as moving, but when I move it over, what I'm really doing is I'm subtracting that x. So when I do that, okay, the x terms will cancel, and you have to rewrite what you have when you add or when you do the first step, which is here we're going to subtract x. When I rewrite it, that turns into, this is going to turn into, I'm going to put it over here on the side, 4y, oops, let me fix that, 4y equals negative 5x minus 12. Okay, now we got to do the second part, which is divide by y, because we got to solve for y here. So we're going to divide everything, each term, by 4. Okay, so when I do that, the coefficient cancels, and now my equation really is y equals a negative 5/4 x minus 3. So now I can graph this. Now, when you graph it, after we solve for y, you're going to, if I have it here, my second step is graph. We're going to graph using y equals mx plus b. And hopefully you remember, when you graph in this form, you have to do the b first, and then you have to use your slope second. So for example, on this, your b right here, your b equals negative 3. Your m equals negative 5/4. You want to always have your slopes as a ratio, rise over run. All right, so let's just do this. That means I start at a negative 3 on the y-intercept, on the y-axis, excuse me, is my y-intercept. And then I'm going, my slope is negative 5/4, so that means I'm counting down 5. 1, 2, 3, 4, 5, and to the right 4. Put a point there. I cannot continue that because I run out of room. So I'm going to go in the opposite direction, up 5, to the left 4. There's that point. I can probably repeat that. All right, so now I'm going to use my line tool, but you would need to use your straight edge, your ruler, to draw that line. Okay, I'm going to just trying to speed up the process here a little bit. So this line should be blue because this is the first equation I'm doing. All right, so we have a line through those points, like such. And let me fix this just a little bit. So it's going through. There we go. Okay, so we have to do the same thing for the second line. We'll make my second line green. Okay, oops. So this one's going to be green. So I'm going to do the first thing, solve for y. So to do that, you have to add or subtract the x. Here we're going to subtract x. Okay. The x is canceled out. We rewrite it. This is going to leave me with a negative 4y equals negative 3x minus 20. Always list the x first. Now we're going to divide by the coefficient of y, so divide by the negative 4. So the cancels out. So this equation is going to be y equals positive 3/4 x, and this is plus 5. Okay, so here's our second equation. And in that equation, our b is 5. So on the y-axis, 1, 2, 3. We have a point at 5, and the slope is 3/4. So that means we're counting up 3 to the right 4. So I can't repeat that because I ran out of room, but now I can go in the other direction, down 3 to the left 4. And right there, at that point right there, I can see these lines are going to cross. Okay, so I'm just going to sketch this because I know there's a solution here where the lines meet. So I'm just going to indicate, I'm just going to draw an arrow. Hopefully you can see I'm pointing to this point, that is our solution. And that solution is the order pair 1, 2, 3, 4, negative 4, comma 2. That is your answer. Okay. So the thing with these on your graphically, solving graphically on Alex, you are going to have to do what we did right here, all this work solving for y on your paper. But on Alex, you would use your points, using your pencil to put the points to draw your line and then to show the intersection. Because they're going to ask for you to graph it, and they're going to ask, I think they're going to ask for this, like this order pair for your solution. Okay, so that's graphically. I wanted to recap substitution. Okay. So there's some things you need to know. So you kind of want to fill in this information, and we're going to practice that on this example. So when you're solving by substitution, one of your equation must be solved for a single variable, meaning it has to be isolated. You have to have one variable by itself. This can be X or Y, but you have to have one side of your equation solving for that variable. So one of your equal signs by itself. So one of the variables on one side of the equal sign. So like if I look on this equation right here, both variables are on the side of the equal sign. We need one. Okay. If your equations are not solving for a single variable, you must isolate your equation, and you're going to have to or solve for the variable. Run out of room here. So you want to isolate the variable in your equation or solve for the variable. All right, so looking at this example right here, you're going to have to pick which one is easier to solve. You want to pick the variable with no coefficient, no number in front of it. So right off the bat, this is the easier one to solve for. Okay, to do that, I'm just going to subtract the 2x, or basically move this 2x over here. Okay, when I move it, it becomes a negative. So what this is really going to be is y equals negative 2x minus 4. Okay, I have now solved for the variable. When you solve for the variable, this is now you have an opportunity to use substitution, because if one equation is solved for a single variable, which is what I have here, you're going to substitute that expression. So that means we're going to substitute this expression, okay, in for the variable in the other equation. So I'm going to substitute in for that y in the other equation. Anytime we use substitution, guys, you're going to need to use parentheses, right? So here's what I would get in the habit of doing. What I circle that I'm substituting, I'm pointing it for y. I'm going to rewrite everything, but now I'm going to use parentheses for that variable. So for example, let me just kind of fix this and make this a little bit better. What I mean is, in the other equation, I have 4x. I'm not substituting the x. Plus 2y. I am substituting that y. So I'm putting parentheses there, and then equals x. What I'm substituting for that y is what I circle. So inside my parentheses is a 2x minus 4. And then from there, you're going to need to distribute and solve for the variable. So here we're going to distribute. Hippity hoppity distribute property. All right. So we're going to rewrite this. We got 4x. Now it's going to be minus 4x. This becomes minus 8 equals 8. So now we're just solving for x. Well, when I do 4x minus 4x, this becomes 0 right here, right? So this leaves me with negative 8 equals 8. This is back to what I was talking about. This is false. This is a false statement. So if that is false, make sure I have my sign right. Yeah. If that is false, then this answer is no solution. And you don't have to go any further. If we did have a value for x, then we would plug it back in and then solve for the other variable. But if we get a false statement or a true statement, then we're done, because it's either going to be no solution or infinite solution. All right. All right. And then the last method I want to talk about before I go over back to what we just addressed, or let's just talk about systems and then we'll go into inequalities, is using the elimination. Okay. Now, with using elimination, this is when we're going to add two equations to eliminate one of the variables. And you have some steps here to refer to, excuse me, to help you. So one, you want to always write the system so that like terms are lined up. Okay, So we need our like terms are lined up. That means your x's are lined up and your y's are lined up. And I'm trying to show you that in the example right here, okay? The next thing you're going to do after that, step 2, it says find or create. Sometimes you have to create by multiplying. Okay, find or create a pair of opposite terms. And here's your example, like 7x and a negative 7x. Okay, so right off the bat on this one, I have opposite terms with my y's because I have a negative 2y and a plus 2y. So I have a pair of opposite terms. So we're going to add them to eliminate them. That's what step 3 says. It says right here, add the equation, solve for the remaining variable. So when we add, it eliminates that variable. What's remaining is, because when I add x and 5x, that's 6x. And when I add a negative 19 plus 1, that's a negative 18. And now I'm solving for the remaining variable. So this would be when you divide by 6 if you need that. No, I know y'all can just do that mentally. So this would give me x is a negative 3. Now, we're not done, because once you have your x, because your solutions are always a pair, an order pair, you are going to need to substitute your answer into one of the original equations and solve for the other variable. So I can plug in the first or the second. It's up to you. I'm going to go, let's go first, okay? So I'm going to plug this back into here. I'm going to rewrite it. So this means negative 3 is my x minus the 2y equals negative 19. Probably should have did that in blue, just so you can see the difference. All right, so to solve for this y, I'm now going to have to add 3 on both sides. Okay, I'm going to change my font here. This is going to leave me with a negative 2y equals a negative 16. Then when you divide by that negative 2, we get that y equals 8. Okay, so now our solution, the solution is the order pair negative 3 comma 8. Right, that's our answer. All right, so let's talk about this second example. Same steps. Line up your terms. All right, we line up our terms. There's our x's lined up. There are the y terms lined up. We got that sign right there. Now, there are no opposite terms here, so we have to create a pair of opposite terms. You create a pair of opposite terms by multiplying. You want to multiply so they have a common factor, common coefficient, so you do look at your multiples. So here's what I'm going to do. So I'm going to do the top one here. I'm probably going to come down to the bottom. I'm going to focus on my x's because I can multiply the 4 by 3 and get a 12. I can multiply 3 by 4 and get a 12. So I can turn these both to 12x's. So the top one here, I'm going to do times 3. So this will be a negative 12x. Then 3 times that minus 8, make that minus 24y, equals 3 times that minus 4, again, negative 12. Okay? The second one, this one, I'm multiplying by 4. And I don't have to worry about any signs because they're already going to be opposites right there. So this is going to be plus 12x. This is going to be plus 24y. This is also going to be negative 12. So now that I've created opposites, we can add them. When I add them, this could happen. This cancels and the y's cancel. So that means this is 0. Okay? But when I add a negative 12 plus a negative 12, this becomes a negative 24. Again, look at that. That is false. So if you have a false statement, like such, your answer is no solution. Okay, so that takes care of that. All right, so I'm going to do, I'll just go to the next part of the playlist to talk about solving inequalities, because there's some things, a couple of steps and some additional notes we need to add here. So I'm going to pause this or you can just hit the right arrow so you can go to the next one, because I'm going to turn this into a playlist of the types of things you need to know. All right. Thank you. And